This is the GATE AIMER'S and this is the first subject, and this GATE AIMER'S, as we specified yesterday, is going to cover up all most important topics that you should necessarily study in the past 3 months. If you have studied, you can revise through this series. Even if you have not studied, this series will help you get good number of marks in the GATE examination. Just be relaxed and assured about that. Very good evening all. Let's get started. So I hope all of you are fine, doing great, and especially doing great with your GATE 2023 preparation. Good evening all. Keep joining the session. Very good evening, right, to all of you. Yes, I am also fine. Raghu, good evening. Raghu, Dreamer, Sai, Tanush, Ashok, Anil Bharti, Satyashri, very good evening to all of you, and quickly update your friends, juniors, everybody preparing for GATE 23 that yes, if they were looking for a free crash course to cover up all subjects, yes, all of your subjects, and this is the crash course that is going to be there for ECE, EEIN as well as computer science on this particular YouTube channel. Okay, so if you are one of those, willing to revise through the crash course, willing to prepare through the crash course, this is going to boost your performance. And yes, I repeat, all your subjects of GATE will be completed. It's not about one digital or control, network, signals, EDC, analog, communication. For electrical, there will be power system, power electronics also. So, quite from some time, many students were demanding that power electronics is not happening on this channel. Yes, now Ashu Jhangra sir, as you know, as we yesterday told you, the entire ECEE team is there in this channel now. So even the power electronics type of subject, very expert Ashu Jhangra sir is going to deal with that. So complete solution for all ECEEIN and CS students will be there, right? Second year, third sem, yeah, it can help you understand, Devankan, what the GATE level is, and if you are willing to prepare in the future, this will give you slight idea. Although because you are in second year, third sem, you can even prepare with more details, but you'll get an idea how GATE preparation must go on. Good evening, Surya, Satvik, Jayesh, Bhaskara, right? Bhaskara, yes, it is possible to crack GATE, depending now how much time you are able to give. 3 months is definitely a less time, but if you are ready to give your full around 14 hours, 13 hours, so you can get some decent good performance in the GATE examination. So chalo guys, start karte hain. Let's not wait anymore. And this is a brief intro about me. This is your mentor and educator Rakesh, and I have secured all India rank 9th in the GATE examination and completed my masters from the Indian Institute of Science, Bengaluru. And these are my major area of expertise that I have been dealing for more than 12 years now. Right. Okay. No, Tanush, my rank was, among the top. So I was given, for microelectronics, there was a direct admission that time, and hence I had the privilege of getting the direct admission for the microelectronics branch. Okay. Right. Chalo. So let's get moving forward. Jayesh, the structure is like very simple, depending on topic to topic. Some topics will be taken with the help of questions. Some talking where are more important, where you need understanding, will be taken through concepts. The idea is if you go through any subject, you will be scoring good in that subject, comfortable in that subject, because we are picking the most important topics of every subject. It's not like because last 3 months, 100% you cannot cover also in this much of time. We also cannot cover, but we will promise to cover all the important topics jahan se question aata hai. That is going to be the target. Yes, you will get the PDFs of this. You are going to get the PDF, don't worry. But the PDF, like all my previous sessions, is going to be password protected. Sir, what is the password? I will tell you somewhere, anytime at random in the session. Maybe in the beginning, maybe in the end, I don't know. Some randomly created password at some random time I'm going to tell you, and that is the password that will be there to open the PDF. That means whoever are watching the session, they are going to get the benefit of this. Okay guys, yeah, before we move forward, one more quick update for you that tomorrow, Tuesday, 15th October, all your favorite Josh Singh sir is going to come live on the BYJU'S Exam Prep app. Yes, this is the event on the app, and for all those planning for GATE 24, or if your juniors or colleagues are prepared planning for GATE 24, you can update this information to them that yes, how to ace the GATE examination, GATE 2024 examination with the college or the job. Tomorrow on the BYJU'S Exam Prep app at 8 p.m. Do not forget to join live, especially if you're a GATE 24 student willing to prepare with college and job. How to balance the preparation, that is what is going to be talked about. So guys, Boolean algebra, let's have a quick review because it's a revision type of crash course. So we'll focus on what type of questions are there from Boolean algebra logic gates. Okay, but yeah, a basic review of the some identities that I should present in front of you. Okay, so very simple identities, and then we'll take up the question practice from this. X plus 0 is x. Achha, I will also highlight which are more important. First, starting with the single variable, x plus 0 we all know is x. Now every identity has its dual. Every Boolean theorem has a dual. What is the meaning of dual? What is the meaning of dual of any theorem? What is the meaning of dual of any theorem? The duality principle in Boolean theorem says that, I'm not talking about dual of a function, wo separate, we'll talk about that also. What is the duality principle in Boolean theorem? It simply says that in any Boolean theorem, if you replace all the plus with dot and all the dot with plus, all the zeros with 1 and the ones with 0, that means plus to be replaced by dot, exchange sign bana diya, and the 0 to be exchanged by 1, the Boolean theorem still remains true. Now dekho, x plus 0 is x, that is all very clear to us. X into 1 is x, that is also a separate identity. We know x into 1 is always equal to x. Now look into from the duality point of view. I replace the plus by dot and I replace the 0 by 1. So x into 1 equal to x. Yes sir, that is also a Boolean theorem. This you can apply to any Boolean theorem. So in any Boolean theorem, if you exchange plus and dot, and at the same time if you exchange 0 and 1, then the new theorem obtained is also remaining true. That will also be a true Boolean theorem. Correct, Aji? Sorry. Right. X plus 1 in Boolean we all know is 1. Right. 1 plus anything is 1. X into 0 is x. Again, you can relate by duality, but we also know multiplying by 0 is, oh, sorry. That's a typo error. X into 0 is 0. That's a typo error. I don't mind that. Okay. X plus x is x. It's not a mathematical calculation. We write 2x. In Boolean, 1 plus 1 is also equal to 1 only. Okay. Or 1 plus 1, high plus high is equal to high. X into x is equal to x. Complement of complement cancels each other. So you get x. X plus x complement, because x and x complement are in the complement of each other. Matlab any one of them will be 1, another one will be 0. So if any one of them is 1, answer always remains 1. Okay, similarly one of them is 0. So when you multiply x into x bar, that will be 0. Okay, what are the important theorems from the multivariable 2 or 3 variables? Right, commutative you all know, you can swap the variables x plus y, that is equal to y plus x, or x into y is y into x. Associative law ki baat kare, so x plus y plus z is x plus y plus z. Matlab you can perform the addition of any two. Similarly applicable for the multiplication. Distributive theorem. Right. Now from here one important result to be concluded that I will highlight separately. X into y plus x into z. Simply take the x common, I get y plus z. So x into y plus z. Now apply the dual of this. Important point is apply the dual of this. So what does duality says? When you apply the dual of this, x plus y, don't look into the right hand side. Replace the dot by plus. Right. Replace the plus by dot. X into z hai, so I will write down x plus z. So there is one more distributive theorem that is written by dual x plus y into x plus z. That should be equal to how much? X. Dot is replaced by the plus. Y plus z should be written as yz. X plus yz. X plus y into x plus z is x plus yz. All okay? X plus y into x plus z is x plus yz. ठीक है जी? That is what is the dual of this theorem. That is what is known as the dual of this theorem. बहुत ही बढ़िया. Okay, now x plus y into x plus z is x plus yz, na? Let's stop for a moment here. X plus y, this is going to fetch you an important result, into x plus z is equal to what? X plus yz. X is common plus yz. Now, taking the motive from this, what should be x plus y is multiplied by x plus y dash. X is common, but one is y complement. X plus y and x plus y complement should be equal to how much? Try करके देखिए ना. Should be equal to how much? Should be equal to how much? Should be equal to x plus. Should be equal to how much? X plus y into x plus y bar should be equal to how much? Come on. Right. Yeah, we'll come to propagation delay question also, Altaf, don't worry. This should be equal to how much? Y into y bar. This should be equal to how much? Y into y bar. Right. That is equal to y, and this is simply equal to y into y bar is 0, that is equal to x. So x plus y into x plus y bar is equal to x, is equal to x, right? is equal to x. Is that okay? Is that okay, everybody? Is that okay, everybody? ठीक है. अच्छा, if I write down x plus y, x bar plus z, can you have any expansion for this? X plus y into x bar plus z. Is that okay? Chalo, let's go to the next one. Okay, so x into y bar. This is going to come in the question. मतलब ये question में use होता है. Okay, now let's go to the next. X plus xy is equal to x. You can take the x common. Nothing great here. Simply x into x plus y is also equal to the x. Is also equal to the x. Okay. Now x plus y. Very famous De Morgan's. Very famous De Morgan's. X plus y whole bar is x bar into y bar. X into y whole bar. Complement of multiplication, whole multiplication is addition of individual complement. So x into y whole bar is x bar plus y bar, applicable to multiple theorems also. x1 plus x2 etc up to n variable whole bar is x1 bar x2 bar etc. But इसको duality से solve करेंगे. Similarly, x1 x2 etc xn whole bar, multiplication whole bar is addition of individual bar, x1 bar plus x2 bar plus x3 bar and etc. Okay, correct. Right. Acha. That is what one more theorem. Let me write down here. If this is true, one more important result from here. X plus x bar y. One is x plus y into x plus y bar. That is always equal to the x. What is x plus x bar y? What is the x plus x bar y? Now apply the reverse of this theorem. You get how much? You get x plus y. Z is x plus y, x plus z. Distribute this. So when I distribute this, I get x plus x bar dear is multiplied by x plus y. X plus x bar, x plus y. But what should be x plus x bar? That is equal to the 1. That is equal to the 1. Now this is also a very commonly used point in the question. X plus x bar y is x plus y. X plus x bar y is equal to the x plus y. Right? All okay. This is also important. This is actually very important, very commonly seen in the questions related to direct Boolean algebra or the logic gate type of structures. Okay. Regarding to the De Morgan's theorem, I am telling that you can even go by the dual method. Now, what is the dual method? Suppose there is a function given to you, right? A plus, very simple example, let us take a plus b bar c. And if I want the complement of the function, you are given the function a plus b bar c and you want the complement of the function. One thing is, right? Yeah, combinational tomorrow. After that, flip-flops, counters, Venkatramana. Don't worry. Okay. So what is f bar? So one logic is you will apply the De Morgan's law. A plus b bar c whole bar. Now this is like x plus y whole bar. So this is x bar into y bar. Right, this is further equal to a bar. Now x into y whole bar is x bar. Now b bar ka bar will be b. Bar ka bar cancel. Complement cancel. So you have the answer a bar into b plus c bar. Right. What you can directly do, guys, is you are given a plus b bar c. Okay, first of all, you are going to write down the dual of the function. What is the meaning of dual of Boolean function? Is simply exchange all the plus and dot. Exchange all the plus and dot. So a plus will become a dot. B bar into c will become b bar plus c. Is that okay? B bar into c will become b bar plus c. Now complement each and every variable. So what is the f complement? A complement into b complement ka complement is b plus c complement. That is what is your answer, na? That is what is your answer by the De Morgan's. So simply, in one line to apply De Morgan's, just take the dual of the function and individually complement each variable. And this should not be a two-step activity. इसको आप one step में करेंगे. This should not be a two-step activity. So suppose if I give you a bar b plus ac, very quickly, a bar b plus ac bar. So what is going to be the complement of this function? You should be able to write down very quickly. तो एकदम quickly कैसे लिखेंगे? So first take the dual and after simultaneously invert each and every variable. So dual means plus and dot. Exchange the plus and dot. Inverting every variable means a bar will become a, dot will become plus, b will become b bar. Again there is a plus. I will write this as dot. उसको dot लिखेंगे, right? Then a into c bar, a bar plus dot becomes plus, c bar becomes c. That is the complement. Very simply you are going to write that. That is the complement. Very simply you're going to write that. Okay, yeah, dual, that is what I've explained here, the dual. Acha, now tell me one more thing. Right? If I write down xy plus xz plus yz, all possible pair of product with respect to three terms, xy plus xz plus yz. But my question is not xy plus xz plus yz. This is actually a majority function. We will study that especially when we are talking about carry functions and all. Yahan pe tell me, if I take xy plus x bar z plus yz, xy plus x bar z plus yz is equal to how much? Now, I am not asking you to derive this. And we are not here to, in this crash course, we are not focusing on deriving, and especially things like Boolean. We are here to focus on the results and the questions. Dono cheez karenge. Formula, results, discussions, questions. What is this? Now, why I am asking you a question? Because this is a result that is a standard result, must be known to you. Anybody? This is a very important theorem. It was not in the list, so I am writing down separately. I thought list mein hoga. What is this? xy plus x bar z plus yz without solving. If you are solving, that is a waste of time. You should know that. You should have known this. Okay. Write down the result. Also write down the name of the theorem. Also quickly write down the name of the theorem. I am waiting for you guys. Quickly. I want the answer from you. xy plus x bar z plus yz. Right. Yahan pe yz hai and yahan pe x and x complement. Okay. Right. Yes, Prince, and say the answer also quickly, everybody. Say the answer also. I'm waiting for your answer. Then let's have some rapid fire questions. Okay, Ahmed gives the correct answer. Ahmed here comes with the correct answer. Yes, Ravi and Prince, the name of the theorem is correct. Right. YZ. So see guys, x and x complement is there. One, it's multiplied by y. One side it is multiplied by the z. Okay, then there is a product term yz, so that product term yz will be redundant. Okay, we can prove, but abhi zarurat nahi hai. So the result is given by, answer is xy plus the x bar z. Xy plus the x bar z. Very, very correct. This is what separately I am writing. This is what is the consensus theorem. Oh, sorry. This is what is the important consensus theorem. Correct? So you should know this. Chalo. Now let's start with some simple questions now with Boolean logic, with the Boolean and with the logic gates. Now, of course, guys, now at this particular point of time, what we are going to revise, what is AND gate, OR gate, you must be knowing this. Yeah, we will take up directly the questions of logic gate related to the Boolean theorem, and then we will go towards the universal logic gate design. How the questions are important from the NAND gate, NOR gate, how many NAND gates required, how many NOR gates, those type of terminology, how to solve the logic gate delay with the propagation, logic gate question with the propagation delay, right? Those we will focus. But I don't think you require right now what is AND gate, NAND gate, XOR gate. This is all you know. So let us focus now on some of the quick questions. So in the logic equation, some equation is given to you. If C is equal to A bar, then what should be the result? Quickly, everybody. What should be the result if C is equal to A bar? Let's do it very quickly. So everywhere replace C is equal to A bar. C is equal to A bar. Right. Let me just write down A plus B bar. If C is A bar, so what should be the C bar? Everywhere C bar coming will be replaced by A, right? Plus C, which is A bar. Okay, then plus B bar. इसको यहाँ separately लिख देते हैं. I need little bit more space. Okay, so plus I have B bar into C. C की जगह आएगा A bar. Already A bar plus BC, and C is equal to A bar. Right, is whole multiplied by A plus B bar C. C is equal to the A bar plus AC bar, that is AA. Everybody, then which of the options is correct? Now everybody, A plus A bar is 1, na? A plus A bar is 1, and 1 plus anything is 1. Okay, so we have A into 1. Can I say directly, na? A plus A bar is equal to the 1, and 1 plus anything is equal to 1 in the Boolean world. So this answer is A into 1 plus the B bar, dear. Plus the B bar. A plus A bar is, yahan se what you can do? Okay, you can clearly take A bar common. You can clearly take the A bar common, and 1 plus B. 1 plus anything is 1. So only A bar is left. Okay, yahan se what you can do? First you take A plus A is equal to A. Okay, let me write down this. This is A plus A bar B bar. What will be the result corresponding to this? What will be the result corresponding to this? Acha, this is equal to 1. ये भी ध्यान रखना है. This is given equal to 1. Okay, this is given equal to 1. Right. So that means this is equal to 1. Now, this means, देखो, A bar into A is 0. In second term, B bar into B bar. ये वाला आ जाएगा यहाँ पे, right? So we have A plus A bar B bar equal to the 1. First term is 0, A bar into A, right? Second, B bar into B is B bar. Now, what is the answer? A plus A bar B bar, X plus X bar Y is X plus Y. So, A plus A bar B bar. Complement will be absorbed. Complement will be absorbed. The answer will be A plus B bar. Okay. A plus B bar equal to the 1. So, what is the correct answer, dear? What is the correct answer? C is ready for me. A plus B bar equal to 1. Everybody check on quickly, guys, quickly. See, yes, Prince, correct, right? Yes, Ahmed, correct. And do not forget to like the session if you are energetic, if you are motivated, if you are enjoying. Do keep liking the session. Quickly, next question. The Boolean expression simplifies to very simple question. Okay, very simple question. So even previous one was simple. This is mostly the level that then we'll relate these questions with the logic gates also. Come on. So this Boolean expression simplifies to how much? This Boolean expression simplifies to how much? X plus Y bar. What should be the result? X plus Y bar. Abhi humne discuss kiya tha na, this should be equal to the X. How much is this portion? This is equal to the X. Distributive theorem, X plus Y bar, that is equal to X. Okay, from here, what is there to be simplified? First of all, X bar, isko reverse kar dete hain. X bar plus XY bar ka whole bar. Now, X bar ka bar is X. That means somehow this is the complement of X bar that is going to be absorbed. This is going to be absorbed. So here you apply the absorption. This is going to be cancelled. And this is now X bar plus Y bar whole bar. And that is according to De Morgan's XY. According to the De Morgan's, that is XY. So your answer is X plus XY. X ko common liya. 1 plus Y is always 1. So your answer is equal to X. So your answer should be A. Check on everybody. Your answer should be A. Correct, Prince Ji. Right, your answer is equal to A. Next question ready for you. If P, Q, R are the Boolean variables, then P plus Q bar, P, Q bar plus PR, P bar, R bar plus Q bar simplifies to the how much? Simplifies to the how much? This is again simple because yahan se dekho P common le liya. I have P plus Q bar. Now, what is the role of this P? Okay, let me just show you step by step. Ye ho gaya Q bar plus R into P bar, R bar plus Q bar. Now what happens when you multiply this P with the P bar? That is cancelled. So you have P plus Q bar. Okay. Then you have Q bar plus R. P went inside. So that is PQ bar. This was cancelled. And then you have only PQ bar. Then you have only PQ bar. Come on. Yes. Right. Now, if you multiply here, P into P is a single P. So this is PQ bar. Q into Q bar is a single Q bar. Q into Q bar is a single Q bar. So this is PQ bar. Okay. Again, you can take the P common directly. Okay. So Q bar plus Q is equal to 1. Q bar plus Q is equal to 1. You are left with Q bar plus R. You are left with the Q bar plus R. Correct. Right. Yahan pe P into P multiplied. It was a single P. PQ bar. This is Q bar multiplied. So that is PQ bar. Okay. So PQ bar plus PQ bar. Oh, sorry. I'm sorry. It was the same. PQ bar plus PQ bar. Okay, that is one single PQ bar into Q bar plus R. Right, so this is PQ bar, Q bar plus R. Okay, now this is finally equal to how much? This is finally equal to how much? PQ bar plus PQ bar R. Right, PQ bar plus PQ bar R or Q bar into P plus R. P को कॉमन भी ले लेंगे तो Q बार प्लस R. ओके, ठीक है. If I take the P common, it is Q bar plus Q bar R. Now tell me the answer. Q bar will be common. Right, PQ bar plus PQ bar R Q bar is common, so you are left with P Q bar. 1 plus R is equal to the 1. No. How it is coming to be A? P Q bar plus R to nahi aa raha hai. No. No. Just check out the answer once. Dekho na. Just check out the answer. What is the mistake that has happened? P into P bar is 0. That is gone. So I have only written here. This is P plus Q bar plus R. Yeah, यहाँ पे आप distributive भी apply कर सकते हैं. You can also do one more thing here directly. Q bar plus P, Q bar plus R. So Q bar plus PR. That is also a possibility. And then you multiply by P Q bar. कैसे भी जाना है? That is your call. Okay, that is your call. No. Yeah. And now everyone has corrected. So that is sorted. That is sorted. आप इसको ऐसे भी ले सकते हैं. Answer is anyways P Q bar. So I think not some of you, most of you made the mistake in hurry bari. देखो, Boolean is very simple, Boolean theorem, but hurry bari can make you lose the problem. Patience and with the correct approach. Now think what mistake you have done. Okay, so even if I go this way, Q bar into Q bar is single Q bar, P Q bar plus this is again P Q bar R. Okay, or that is again P Q bar, common liya 1 plus R. Answer is P Q bar. Anyways, either ways you go, answer is C. Answer is C. Okay, chalo, all okay. C is the correct answer. So be very careful. Be a little bit careful also while you are dealing with the questions. Okay, so next question. If xy is equal to 0, then what should be the x XOR y? What should be the x XOR y if xy is 0? So we all know, independent of any condition, no, Raghu, not yet. Independent of any condition, x XOR y, everybody knows. xy bar plus xy bar, independent of the given condition. But agar xy is 0 hai, then what is going to be the result? If the xy is 0, then what is going to be the result? Then what is going to be the result? That is the smart thing you have to do, right? That is the smart thing. xy is 0, then what is x XOR y, right? So xy has 4 possibilities. 0, 0, 0, 1, 1, 0, 1, 1. But here, 1, 1 will not come. xy is equal to 0. That means x and y both cannot be equal to 1. This is not the correct possibility. This is not the correct possibility in this truth table. In this truth table, this is not the correct possibility. So your answer is, okay, now what is x XOR y? It will produce the high output when both the input bits are different. So it will produce 1, 1 here, no doubt. It will produce the 1, 1 here. Okay, but what about this? Okay, this is going to be x. X means not the input x, this is the don't care x. This is the don't care x. This is going to be treated as don't care x. Okay. Now, if you take the don't care, no need to go for K-map. Logically, I can say, right? If you don't care is in your choice, na? You can either take it as 0 or 1. So see, if you take the don't care as 0, then it becomes a proper XOR truth table. Then it becomes a proper XOR truth table. Answer will be x bar y plus xy bar. सुन लीजिए पूरा. पहले पूरा सुन लीजिए एक बार. ठीक है. लेकिन अगर x को 1 लिया, suppose if I take the x equal to 1, then what should be my answer? If I take the x equal to 1, this becomes a truth table of a very simple OR gate. Very simple OR gate, and the answer should be x plus y, isn't it? So what is the reduced answer? Very simple, it is x plus y. Na? Don't care can be either 0 or 1 based on whether it is able to minimize the answer or not. So yes, if I take x is equal to 1, the x XOR y will be x plus y, treating don't care equal to 1. Check. I think it's fine now. Maybe suddenly it buffered. I also didn't come to know. You just mentioned in the comment box, then I noted that. Kindly check, it should be all okay now. All right, now okay. Chalo, okay. Now let's continue. Okay, so A, B and the Y. A, B and the Y. Ab dhyan dena. What is going to happen here na? What is going to happen here? AB, let us write down all 4 possibilities. 0, 0, 0, 1, 1, 0 and 1, 1. But what about the AB? What about the AB? We can write down, na? Right? We can write down. Okay. AB, 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1 is 1. Now, what is a 3-input XOR? Apply the logic of 3-input XOR. The output of 3-input XOR is high. The output of 3 input XOR is high if the input string contains odd number of ones. If the input string contains odd number of ones, तो यहाँ पे कितने ones हैं? Nil. Output is 0. How many ones? Single one, odd number. How many ones? Single one, odd number of ones. How many ones? Triple one. 3 ones, odd number of ones. Whenever the input contains odd number of ones, the output should be high, and the output is high. Now we have to write down output as a function of AB. There are only 2 variables, right? So if you compare the output Y as a function of AB, right? If you have to write down Y as a function of only AB, so if you compare with this portion, output is high at the last 3 places. That is an OR gate, na? Output is high if any of the input is high. If any of the input is high, that is the OR gate, dear. That is the OR gate, right? So if you have to take it as a function of AB, answer is A plus B. So my answer is option number C. Option number C. Simple. Tanush, nothing. I just told that if you apply a XOR formula in this question, it's going to be lengthy. Rest I told, solve by the truth table, and that is what is in front of you. Sai Tanush. ठीक है जी? Tell me, और भी कभी कोई mistake, और भी कभी कोई error हो, if you have any confusions, please do keep telling me. Do keep telling me. Okay जी. Chalo. Next question ready for you. Now let us mix that Boolean logic with some logic gates question also. And again I tell you ki I don't feel now at this point of time, it's mid-November, where we should study what is OR gate, AND gate, XOR gate, XNOR gate. We should Boolean theorems, some important Boolean theorems we revised as theory. Isme theory ka zarurat nahi. Let's solve the questions, different type of questions here. Okay, so what is the output of the following logic circuit? The question is, what is Y equal to? What is the Y equal to, sir? Nikal lete hain. Badhiya. What is the Y equal to? So have a look into this. Okay, let's solve, okay, by gate to gate, A, B bar. Okay, this is the complement. This is the bubble representing the inverter here. Okay, this is AB, output of AND gate. So what is here? Now every step, let's apply the theorem. AB plus B. AB plus B. AB plus B is equal to B into A plus 1. A plus 1 is A, so this is equal to B. Every step, let's write down the answer, right? Okay. Correct. See, if it is given, Sai Charan, if it is given as expression A XOR B XOR AB, right? Then you can take the first XOR, again not by the formula, first XOR by the XOR truth table and then take it with the XNOR of AB. You know both the truth tables. Still solve by the truth table only, Sai Charan. Okay, chalo, yahan pe kitna answer aayega? What is the answer that is going to come here? A, B bar plus what is the output of this gate? This is eventually B. So this is like, once again guys, B plus B bar A. B and B complement with A. So the complement will be absorbed. And the answer is B plus A. Okay, now let's come here. Okay, what is the output coming up here? Upar se aaya A plus B multiplied by the B. This is still equal to how much? A plus B multiplied by B. Dekho, this is AB plus B. B is a B. Right, so again B common, A plus 1 is equal to A is equal to 1. So you again get B. Okay, now what is the final output? Here I have got B. Okay, so B plus A. It is simply as simple as a OR gate. It is as simple as a OR gate. So my answer is A plus B. Answer ko A mark kijiye, aage badhiye. The correct answer is the A plus B. Answer is A plus B. Y is equal to the A plus B, dear. Y is equal to the A plus B. Let's move ahead to the next question. What is the output Y in this circuit? What is the output Y in this circuit? Now, this is to be solved by logic, not by formula again. We never have to have formula based question in a subject like digital. It has to be solved by logic. That is why we call it as the digital logic. Boliye. Right. Now, everybody see, if you apply the formulas of XOR, it's going to be lengthy. Here you have A and B bar. Some properties of XOR. Guys, what is A XOR B bar? Right. or A bar XOR B. In the XOR, if you complement any one of the variable, it behaves as a XNOR gate. It behaves as a XNOR gate. Number 2, if you complement both the variables, A bar XOR B bar, then it is same as XOR. Then it is same as XOR A XOR B. Then it is same as the XOR A XOR B, correct? So A bar XOR B bar is equal to the A XOR B, everybody. This is equal to the A XOR B. ठीक है, तो चलो आगे बढ़ते हैं. Right, आगे बढ़ते हैं. Okay. Similarly, so what is this? This is simply A XOR B bar. So this is A XNOR B. But second one is A XOR B. Now C bar XOR D bar, both are complement. So this is C XOR D only. C bar XOR D, only one of them is complemented, so it becomes XNOR. अब देखो, property plus logic to be mixed. Now, good question. It is a good question. Good. अब देखो, A XOR B, A XOR B and A XNOR B. Both are complement of each other. XOR and XNOR complement होता है ना एक दूसरे का. तो if you apply that logic, one of them is high, one of them is zero. One of them is high, one of them is zero. So I can say that, right? I can say that this is one of them zero. Right, what is the result? One of them will be 1, another one will be 0, another one will be 0, right? So you get a single 1 from here, right? Similarly, this is XOR and XNOR of the same two variables, so they are again complement of each other. So again, one of them is guaranteed to be high, another one will be low. They cannot be in the same state. So one more 1 you get here. One more 1. Now, Y is finally the output of a 4-input XOR gate. What is the output of a multi-input XOR gate? Dear, what is the output of multi-input XOR gate? It is equal to high when the input string containing odd number of ones. So total कितने ones हो गए? Everybody, how many ones are you able to see in front of you? Total 2 ones, and if there are total 2 ones, even number of ones, the output should be 0 for a XOR gate. Output should be 0 for a XOR gate. So the answer for the question is A. Mark कर लीजिए. The answer for the question is equal to A. The answer for the question is equal to A. Everybody, the answer for the question is equal to A. Isn't it? The answer for the question is equal to A. Okay, so good question. We have to have, see, it's not about good, it's all about the approach. If that approach is smart, then you are on the correct track. If you apply formula, then there's a waste question for you. It is just time. You're going to waste even around 1 or 2 minutes of time if you solve by the XOR formula. Waste. Then that becomes a waste. Okay, chalo. With this next question ready for you. What is the output of the following logic circuit? Now, this is NAND, again followed by a NAND. Now see how you can simplify. Better is, let's take the question here again, and better is, let's call the output is already Y, this is M and Q, so let me call this as A, B, C. Right? Okay. So what is the output? It is A, B, C whole NAND. A, B, C whole NAND. Okay, that is equal to A bar plus B bar plus C bar. Now what is A bar? So what is A? What is coming here? Let me write down clearly. This is M, this is N, this is Q. M and Q whole bar. Let's talk about B. Let's talk about the B. This is M, this is N bar. This is N bar coming up here, and the third variable is Q. इसमें कोई doubt नहीं है. Last gate, this is, let me check, this is coming from Q, this is actually Q, this is N, and this is M bar. Okay, so second one is M, N bar Q whole bar, and third one is M bar N Q, M bar N Q whole bar. Right, now this is M and Q whole bar, that is actually equal to A. I want A bar. Dear, I want A bar. So one more bar. So this is actually equal to bar cancel. M and Q, M N bar Q, M bar N Q. Okay, no need to go for K-map. This is a basic Boolean logic question, right? The first two parts will contain MQ. Looking into this, you are able to say, na, MQ common, n plus n bar is equal to 1. N plus n bar equal to 1. So MQ plus m bar NQ, right? So that is M plus m bar n multiplied by Q. M plus m bar n, M and its complement multiplied by n. So complement is absorbed. Complement will be absorbed, right? So I get M plus N whole multiplied by Q. MQ plus NQ. MQ plus NQ. MQ plus NQ. Right. That is MQ plus NQ. D. Yeah, that is what I have written. Q common, M plus N. Option number D. Option number D. Is there any sound issue? Let me just also try to listen to that one. Hello. इस पे वॉइस नहीं आ रहा क्या? जस्ट अ सेकंड. Option number D. Is there any sound issue? Let me just also try to listen to that one. Some glitch is there. Just a second. Hello. इस पे वॉइस नहीं आ रहा. Hello. Let's see the word is now. Okay. I'll just try to reset that. Check करते हैं एक बार. Hello. Let's see the word is now. Okay. I'll just try to reset that. Check करते हैं एक बार. Okay, let's move it out now. Let's move out now, guys. Come on. Okay, so this is the answer to the question. MQ plus NQ. MQ plus NQ. Okay. So these are some good practice questions that you should deal with. Audio hai, right? Audio hai. Answer to the question. Yes, audio is there. Okay, audio is there. Let us move on. Okay, let us move on towards the next case. Let us move on towards the next gate, that how NAND and NOR, okay, behave as universal gate. How the NAND and NOR behave as the universal gate. Okay, and what are the type of questions expected from here? That is more important. What type of questions are expected from here? That is more important. Kya ho raha hai? Some issues there. Just a second, yaar. As the universal gate. Okay, and what are the type of questions expected from here? That is more important. What type of... Yeah, I think it is clear now without any buffering. Some connection issue I think happened. It should be now clear, don't worry. Refresh it once twice. I think that is okay. Just refresh that once. If you are lagging, na, just refresh your browser once. Refresh your YouTube once. Or click to the live button directly so that you don't lag behind. I think that's fine. Chalo, let's move ahead. Okay guys, so everybody, let's follow. Okay, so NAND as the universal gate. So now again, let me tell you that what are the type of questions from here. I'll tell you the method and the procedure and the type of question also, but how NAND behaves as an inverter. This is how it is an inverter. When both the inputs of NAND gates are shorted to each other, they are commonly tied. So this is A. So it is very simple. Both the inputs are A. So this is A into A whole bar, and A into A is A. So this is an inverter. So the first structure shown in front of you is the NOT gate. If I want to talk about second, let's say the inputs are AB. So this behaves as a NAND gate AB whole bar, but this is again the NAND gate when both the inputs are shorted. So this is an inverter. If this is an inverter, the output should be AB bar ka bar, complement of the input. So that is what is AB. So this is an AND gate for me. This is an AND gate for me. So by the way, what is that universal logic? What is the meaning of universal gate? Any gate is a universal gate if it is able to implement any basic gate. Because if you get any basic gate, you will be able to implement any Boolean function also. Because any Boolean function on the first level can be drawn using AND gate, OR gate and the NOT gate. So gate is a universal gate if it is able to implement and, or, and not using sufficient number, using any number of gates. It could be 1 gate, 2 gate, or even the 3 gates, right? So here, if I take the third description here, so what is this? This is again NAND gate, both the input shorted. This is the inverter A bar. So this is the inverter for B. This is B bar. Okay. Now this is again a NAND gate. Okay, where you take the input as A bar, B bar. So A bar, B bar ka whole bar. The NAND gate is X into Y whole bar. And according to the De Morgan's logic, this is going to be A plus B. So this is the OR gate for you. This is eventually the OR gate for you, right? So this one is a NOT gate. This one is a AND gate, right? This one is a OR gate. So how many NAND gates you require for an inverter? A single one. For an AND gate, 2, and for a OR gate, 3. That is why when there are more product-like terms, product-time terms like AND gates, we prefer the NAND gates. I will tell you about this theory also. Similarly, XOR gate, now just you can go and trace it out. This is the standard answers. No need for any derivation or standard discussions here. This is how the XOR gate will be. Even if you want to tally, once we'll quickly say that this is A, this is B, this is AB. This is the NAND gate using AB both, so AB whole bar. Now what is going to be the answer here? This is AB whole bar ka whole bar. That is a NAND gate, and that is equal to A bar plus AB. A bar plus AB according to De Morgan's, and A bar plus AB mein A will be absorbed because A is the complement of A bar. If this is absorbed, just a second. If this is absorbed, you get A bar plus B. Right. Similarly, what is the result here is B multiplied by AB whole bar NAND gate. So this is B bar plus AB, B bar plus BA, I can say. And in this, B will be absorbed because it is the complement of B bar. So you get B bar plus A. Now, when you take the NAND of this, you are going to get your desired answer. So what is the output here? A bar plus B multiplied by A plus B bar ka whole bar, right? Apply the De Morgan's with the duality method in one single step, right? In one single step, A bar becomes A, plus becomes dot, B plus B becomes B bar, plus dot becomes plus, right? A becomes A bar, and again that plus becomes dot, and B bar becomes B. So A B bar plus A bar B, that is what is XOR. That is what is the XOR. Okay, so for XOR you need how many? You need the 4 NAND gates. Okay, for XNOR I need one more NAND gate. Okay, this is what is the XOR functionality. We need one more NAND gate to invert. Right? So A XOR B, right? This becomes A XNOR B because this is the inverter when both the inputs of NAND gates are shorted. Okay. Similarly, NOR as universal gate, the standard slides, go through it. I'll share you the PDF. No need to repeat this discussion. Okay, so this is one table that you can remember as important regarding to the standard gates, the basic gates as well as the XOR gates. Okay, for NOT gate, if I talk about NAND or NOR, only one is required. Okay, but if I talk about AND gates, 2 NAND gates, but with the NOR, if you require, you can refer to the previous slides, it will be 3, right? Similarly, I've written the result for OR gate, XOR gate, XNOR gate. How many NAND and NOR gates are required? One simple logic is, अब कुछ और बातों को discuss करते हैं यहाँ पे. Okay. There are some standard other representations of NAND and NOR that is going to help you to learn the question. See, there is a procedure. Okay, there is a procedure, circuit implementation using NAND and NOR. Let us not study this theoretically. Let us understand this practically applying on the circuit. Okay, but to understand this, tell me one answer. Let's have one simple discussion here. Okay, suppose I take a standard NAND gate first of all. This is what is the normal logic diagram of NAND gate, everybody knows. This is A into B whole bar. But according to De Morgan's logic, A into B whole bar, according to the De Morgan's logic, A into B whole bar is known as the A bar plus B bar. Okay. So, to implement NAND gate, I can do one more thing. I can use a OR gate. Plus likha hai na? So, I can use a OR gate, dear. Because it is written as plus, I can use a OR gate. What should be the input to the OR gate? The input to the OR gate will not be A, it is A bar and B bar, right? To represent bar, I will use a bubble. And now I will feed A. So this bubble, in any digital logic circuit, this bubble represents the inversion actually. So this is A bar, B bar going to a OR gate. So this is what is A bar, plus B bar, which is same as above. So I can say both of them are the representation of NAND gate. Both of them are equivalent representations of NAND gates. Okay. What do we call them? The first NAND gate structure, dear, is known as AND invert. This is known as the AND invert. AND के बाद inverter लगाओ. And the another one is known as first invert and then apply the OR gate. This is the invert OR. AND invert OR. First here we invert and then apply to the AND gate. So there are two ways of drawing a NAND gate. One is the AND invert regular structure. Another one is invert OR. Or I can say AND gate followed by a bubble. Listen to me carefully. AND gate followed by a bubble is a NAND gate. बहुत ही बढ़िया. दूसरी चीज सुनना. OR gate preceded by bubbles. OR gates having the bubbles at the input is also a NAND gate. तो सिंपल सी कहानी सुन लेना. AND के आउटपुट में बबल लगाओ या OR के इनपुट में बबल लगाओ. Both of them becomes what? Both of them becomes a NAND gate. AND के आउट या OR के इनपुट्स में बबल लगाओ. They both will behave as NAND gate. This is what is the technique I am going to use solving the question. अरे यार, this is still buffering. कुछ तो इशू हो रहा है. Why it's issue. Hello. Yes guys, I think there is some connectivity issue today we are facing for the third time, but it is coming back within few seconds. So guys, I think there is some problem because it has happened for the third time today, probably third time. So don't worry if there is some buffering happening anytime. It is mostly I have seen for 20-30 seconds. So don't panic, don't lose the patience. There is some issue from the internet provider side only, I think, but that is automatically, it is getting refreshed. Okay. So let me also not waste time in putting a complaint right now. I will put the complaint after the class. अभी पढ़ते हैं, अभी रुकेंगे नहीं, अभी पहले पढ़ते हैं, ठीक है, right? So again I repeat, अगर by chance आगे buffer होगा, keep the patience for 30 seconds around. It is automatically refreshed. Okay. Now similarly, if I have to tell you the structure of NOR gate, how can you draw the equivalent structure of NOR gate? One is a regular OR gate followed by a bubble is a NOR gate. That we all know. ये तो पता ही है sir. ये तो पता ही है. This is A. This is a NOR gate. This is A plus the B whole bar. But according to De Morgan's logic, this is A bar B bar. This is A bar B bar. Now what I have to do is A bar B bar multiplication represents a NAND, refers to a NAND AND gate. Okay, but for the AND gate, the input is not A, it is A bar. So bubble. It is not B, it is B bar. So B के साथ भी bubble. Right. So this is A bar B bar. This is A bar B bar. This is known as the A bar B bar. So these are the two equivalent structures of the NOR gates. One of them is OR invert. OR के बाद invert करो. Another one is invert AND के पहले invert करो. So once again I repeat, listen to me clearly. OR के output में bubble, AND के input पे bubble लगा दिया तो ये बन गया NOR gate. ठीक है, ठीक है, ध्यान रखना एकदम बिल्कुल. ये बन गया NOR gate. Everybody, ये बन गया NOR gate. ठीक है. So now with the virtue of this, I have given you some steps. ये steps you can go and read later on. This is for you if you want, not compulsory. आपका मन हो, आपकी इच्छा हो, इसको पढ़ लेना, but not compulsory from my side. These are some formal steps. I will explain you with the help of question. The idea is there are two ways of drawing the NAND. Yeah, let me put it very simple. If you have to convert an AND gate into a NAND gate, what you have to do? Place a bubble at the output. If you have to convert an OR gate into a NAND gate, you have to place the bubble at the input. Similarly, how to convert into NOR gate? OR gate to NOR gate, bubble at the output. AND gate to NOR gate, bubbles at the input. bubbles at the input, bubbles at the input. Okay, चलो आगे बढ़ते हैं. How many 2-input NAND gates? How many 2-input NAND gates are required to implement ABC plus AD plus C bar D bar? Assuming, now even if it is not mentioned, I will write down here. Assume that inputs are available only in the true form. Assume that the inputs are available only in true forms. अच्छा देखो, what is the type of expression dear? A, B, C, it's a product term. AD is a product term. C bar, T bar is a product term, and then you add the product term. This is known as what? This is a SOP expression, na? This is known as a SOP expression, right? And as I told you earlier also, whenever there are more product type of terms, you will use the NAND gates. You will use the NAND gates, right? Okay. That will always give the minimum answer. NAND gate preferred for SOP expressions. एक और चीज लिख देता हूं मैं. At the same time, NOR gate की बात करें, preferred for POS, product of some expressions. ठीक है. तो चलिए, what should be the answer for this question? To find the answer to this question, first let me draw the basic gate diagram. The diagram using the AND gate, OR gate and the inverters. पहले इतना करेंगे, right? So A, B, C. Okay. And only 2 input gates are allowed. So A, B, C को भी split करेंगे. Only 2 input gates are allowed. So I use AB first of all. Okay, in a 2 input AND gate, I get AB. Then I am feeding it to another AND gate where I will feed the C. So this is how I produce ABC. Only 2 input gates are allowed. Okay. Then AD. Then I need AD. Right. Then I need the AD. Right. So this is A. I reuse A. D. I multiply them again by the AND gate. Next is C bar D bar. Dear. Next is C bar. But assume that inputs are available only in the true form. That means C is available. True form. C bar is not available. C bar is not available. Okay, so you have to create C bar. Okay, you have to create using what? You have to create using an inverter. So this is C bar. Then D bar. D bar also not available. So one inverter to be taken here, and then you feed to a AND gate. And then finally OR gate. So दो करके plus करेंगे, right? Because only 2 input gates are allowed. So let me add here AD plus C bar D bar to be finally added with this. Right. This is the output which is named as the function f here. Now this is the basic gate diagram. The first step is draw the basic gate diagram. Then the question is not about basic gate. Question is how many NAND gates are required. Kitna? How many NAND gates? How do you convert this structure into NAND gate directly? What is the shortcut? Listen to the shortcut. कैसे करना है एकदम सीधी सी भाषा में समझिए. What should be the shortcut? I told you to convert AND gate into a NAND gate. Place the bubble at the outputs. तो सारे AND gate के output पे bubble लगाएंगे रे. This is bubble. This is bubble. This is bubble. This is bubble. Bubble at the AND gate output converts it into a NAND gate. Now I am placing bubble, extra bubbles. Will it not change the circuit? It can. Wait for that. उसको भी tackle करेंगे. But first, let's come to OR gate also. How do you convert OR into NAND? Bubbles at the input. Bubbles at the input. So I apply bubble here. I apply bubble here. I apply bubbles at the inputs of all the OR gates. ठीक है जी? Now listen to me very carefully. How many NAND gates are there till now? How many NAND gates are there till now? So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. This is also a NAND gate, na? OR के input में bubble, that is also a NAND gate. So I have 6 till now. Now, very important point. You have placed inverters. You have placed extra inverter in middle of the circuit. Of course, that can change the logic. I don't want to disturb this function f. I have to retain the same function, but in this between I disturb the circuit, I can expect a different output. So वो नहीं होना है. The output should not change. So देखो, here the point to be noticed here is you placed a bubble, but another bubble came in series. This is a single path, na? This is a single path. So if 2 bubbles are coming in single path, so it is like inverter in series. And what will an inverter in series do? Dear, what will an inverter in series do? You have actually placed two inverters in series, if this was X, this is X bar, and X bar ka bar will give you X. So inverter in series will cancel each other, na? So these two are there in series, so they cancel each other. No issue, no issue, no issue, no issue. Okay? What is this? Inverter in series, they also cancel. Koi problem nahi hai, baba. Inverter in series, they cancel each other. No problem, dear. All good till now. Badhiya chal raha hai ekdam life mein. Ab dekho, where is the problem in the life? Where is the problem in the life? You have to focus now here on the problem in the life. The problem here is, this is, dear, a single bubble. This is going to definitely change, but I don't want to change the output F, na? So what I have to do to compensate? Here I have to introduce one more extra inverter. In this path, I have to introduce one extra inverter. Listen very carefully, concentration, good, important topic is going on, right? So here you have to place, right, ye kya hai? Right, you have single inverter. This is a single standalone inverter, right? This is series. Wherever in series, they cancel each other. They cancel each other, right? Whenever there is a single inverter, place an extra inverter here. How do you build an inverter, dear? How do you build an inverter? How do you build an inverter? Using NAND gate. Using NAND gate. So what type of inverter will come here? This is the inverter that I'm going to talk about. Inverter using NAND gate only. Only the NAND gate inverters are allowed. So 6 were done, dear. 6 was done. This is number 7. This is number 7. ऐसा कहीं और problem है क्या? Any more single bubble left? This was a single bubble left. This is also a single bubble left. Right. This is also a single bubble left. Right. Single inverter. So wherever you have single inverter, one more inverter in that path is compulsory, and one more such inverter will contribute to one more NAND gate. 8 ho gaya. Till now it is 8. Till now it is 8. Now let's come to these two. Inputs are available only in true form. Inputs are available only in true form. So you don't have C bar available. That is why I use the inverter. But the inverter has to be built everything using universal gate. Right. So this has to be built using one more NAND gate. So this will contribute to number 9. This will contribute to number 10. Rest all is sorted. Rest all is sorted. Rest all is sorted. And the answer should be 10. Yeah? So let me discard one of them. 7 तो कहीं से नहीं होगा. Let me write down. Let me make the answer as C. It has to be 10. It has to be 10. I think there is some typo error here. The answer is 10. Because only 2 input gates are allowed. So the A, B, C was broken separately. A, D, C bar, D bar. This is a OR gate. This is again an OR gate. Hope 1, 2, 3, 4, 5, 6. This is clear. 2 standalone inverters 8 and 2 for the inputs. ठीक है. यहाँ हम एक काम कर सकते हैं ना. Let's not change the option. Let this be C bar D. Okay, let me change this function actually. Let me change this function actually. इसको तो change कर सकता हूँ मैं. Right. This is C bar D. I'll change the question slightly. This is C bar D. C bar. C के साथ तो bar है, but only C bar D. Right. Then your answer is going to be 9. Then your answer is going to be 9. Okay. Some typo error was there. Okay, everybody. Right. So let me take it as the C bar D. Okay. And if I'm taking this as C bar D, so there is no inverter required in the D path. There is no such inverter required in the D path. And this is directly. So only one inverter to invert C, and that is the 9th one. 9 is the answer. 9 is the answer. Everybody, 9 is the final answer. If you have understood this, let's try to attempt one more question. How many 2 input NOR gates? How many 2 input NOR gates are required to implement the A bar plus B, A plus C plus D, plus plus plus, plus plus plus, right? Plus, so this is sum terms, and then you multiply. So this is what expression? POS, product of sum, and that is why the question is NOR gate automatically. NOR gate. Yeah, Sai Charan, minimum NAND gates or minimum NOR gate. This is the procedure, the shortcut procedure. Tell me, dear. Two input NOR gates required to implement A bar plus P, A plus C plus D. Okay, once again, let me first draw the basic gate diagram. A bar plus B, A bar plus the OR gate. Okay, then you have A plus C plus D, but only two input gates to be used. You have A plus C plus D. So A, C, A plus C. Right. Then you have D, A plus C plus D, A plus C plus D, A plus C plus D. Okay, then they are multiplied. So one NAND gate, one AND gate eventually. ठीक है जी. Now this is the basic gate structure. Yeah. Okay, now it's fine. Now it's fine. I told you na buffer hota hai to keep your patience for few seconds. It automatically returns back. Okay, don't worry, don't panic. Okay, let's continue. Yeah, so revise. How to convert OR gate into NOR gate? Bubble at the output. So bubble at the output of all the OR gates. How to convert AND gate into NOR gate? AND into NOR. Bubbles at the inputs. Pehle, piche ki taraf. Bubbles at the input. Now, whenever, same procedure. Whenever two bubbles are in the series. Whenever the two bubbles are in the series. Arey baba, where is my pink color gone? इसको तो डिजाइन करना पड़ेगा. Where is my pink color gone? Okay, right. Looks good. So bubbles in the series cancel each other. So whenever the bubbles are in the series, you don't have to do anything. They automatically cancel each other. Right. So, acha, what is the count till now? This was number 1, number 2, number 3, number 4. 4 NOR gates were automatically there. Okay. Try to answer finally. Okay, 4 NOR gates were there. But this one is standalone. This one is single inverter. So here there will be one more extra inverter to be built using a NOR gate only. And this is going to be your NOR gate number 5. What else? Inputs are available only in the true form. So you have to complement A. Right, to complement this A, I have used one inverter, and this inverter is again to be designed using a NOR gate only. So this is the number 6. So my correct answer is B. My correct answer should be the B. It is the number 6. It is B. Option number B. Everybody dear, correct answer is option number B. That is 6. Option number B. ठीक है, चलो next question dear. The Boolean function y equal to a plus bc is to be implemented using two input gates of only one type. The minimum number of gates required is to be implemented using two input gates of only one type. Only one type. What should be that one type? Is to be implemented only two input gates of only one type. So this cannot be basic gate structure, because if you draw the basic gate structure, देखो, if you draw the basic gate structure, okay, for BC, ध्यान देना, for BC you need a AND gate, right? But for A plus BC plus you need a OR gate. You are helpless. You need a OR gate. For BC you need to multiply. For A plus you need a OR gate. So you cannot complete this answer by using basic gate, because the question has not told you to use universal gate. Question has not told you universal gate, but if you stick to the basic gate, one is AND, one is OR, you can't complete the answer like that. You can't complete the answer like that, right? So definitely you have to think about universal gate, but which one? NAND and NOR. Okay, minimum bola hai na. minimum bola hai, minimum number. Now you have to think what is the type of expression. This is a product added with some variable. The sum of product, this is SOP, and to get the minimum number of universal gates for a SOP expression, what type of gate you have to prefer? What type of gate you have to prefer? You have to prefer NAND gates, dear. What type of gate you have to prefer? NAND gate is what you have to prefer, all dear. NAND gate prefer karna hai. NAND. You have to prefer the NAND gate, everybody. NAND gate, everybody. Okay. So let's apply the procedure. NAND. How to convert it to NAND? AND के output पे bubble, OR के input पे bubble. Now see for series cancellation. This is series. Acha, how many gates till now? This is 1. This was 2. This series cancelled. So there is no pain. There is no pain. But there is a standalone bubble. There is a single bubble here. Right. To compensate this, I need one more bubble. One more inverter using NAND. So ye lijiye. How to make an inverter using NAND gate? Short the inputs. Okay, so this becomes number 3. Your final answer for the question. Your final answer for the question is 3. The minimum number of gates required will be the 3. Will be the 3. So because it is SOP, question may nothing is mentioned what type of gate, so you have to apply your logic. It's SOP, so NAND. And of course, because it is gate of only one type, I can't use the basic gates. Okay? I can't use the basic gates. All okay, dear? This one is simple. Chalo, great. Let's move ahead. Let's move ahead to the next question based on the logic gate. Yes. All the logic gates shown in the figure have a propagation delay of 20 nanoseconds. Let A equal to C equal to 0 and B equal to 1 until the time T equal to 0. Important question based on delay waveforms. At the T equal to 0, all the inputs flip. That is A equal to C equal to 1 and B equal to 0 and remain in that state. For T greater than 0, the output Z is equal to 1 for what duration? The output will be Z equal to 1 for what duration? Good question based on the waveform analysis. All the logic gates shown in the figure. Okay, just let me see if I have some updates. 1 second, guys. Chalo. Okay, now guys, before we start solving this particular question, I have some quick updates for you, right? That this GATE crash course, as we are discussing, this GATE crash course is live at 9 p.m. daily. This is running live at 9 p.m. daily. Okay, right now we are running with the digital electronics. Tomorrow will be the combinational circuits. Tomorrow will be the combinational circuit. Number 1 update for you. ठीक है, ये हो गया number 1. Okay. Number 2, right? On this Wednesday, Friday, and Sunday, right? Wednesday 11 a.m., Friday 11 a.m., Sunday 6 p.m. Right? There will be network theory questions. Right? That will be taken by Sanjay Rathi sir and all those who are willing to prepare in the bilanguage form. Hindi means of course bilanguage. Questions cannot be Hindi. Okay. So those who are willing to prepare, you are willing to solve important topic network questions, important topics network theory questions by Sanjay Rathi sir. Okay. Wednesday, Friday and Sunday. This is this week. I am telling you about this week. Okay. इस week की बात कर रहे हैं. Okay. Right. So network theory questions in Hindi by Sanjay Rathi sir. Other than that, one more important update for this week. That is Wednesday, Thursday, Friday, Saturday. Wednesday, Thursday, Friday, Saturday. Wednesday, Thursday. Yeah, same channel, only in this channel. So guys, if you are not subscribed, do subscribe the channel immediately. I am talking about this particular channel only. Right. So this will be bilingual. Okay. But no problem. Questions to English mein hi hoga na. Only some discussions can be in Hindi. Wednesday, Thursday, Friday, Saturday will be one of the very important topic, probability. All those who are willing to take a step in the engineering maths also, probability will be discussed. by Ankit Joshi sir. Probability will be discussed by the Ankit Joshi sir. The time would be 5 p.m. So choose whatever is your requirement. If you want to attend digital, keep continuing. If you want some network question, you can attend that also. If you want to continue, if you want to study probability, you have option that. If you want to study all three, you have option of all three. Right? Okay. Okay. Right. Correct. This is what is the update for this week. This is the update for this week. This is a very important topic. Actually, probability distributions. Let me mention that very clearly. Here, probability means probability distributions like binomial, Bernoulli, Poisson, normal, probability distributions. Probability distributions. ठीक है. मैं भी लेके आऊँगा बहुत जल्दी. तनुष, don't worry. ठीक है. No, that is different from the crash course. So crash course will keep running. These are some additional practice classes other than the crash course. Crash course will all have all subjects, but other than crash course, now this when Sanjay sir is planning network, this is purely focused on the question practice of most important topic. मैं भी लेके आऊँगा maths. Don't worry, I'll also take maths. Okay. Aptitude weekend as I've planned. Maybe this weekend, one very special aptitude class I'm planning. I will confirm you in 1 or 2 days. Stay tuned with me. Okay. No. Right now for ECEE, INCS, IN Datta. Okay. This weekend, maybe we'll have an important special aptitude class. I'll update you in 1 or 2 days. Okay. I'll update you in 1 or 2 days. Okay. चलिए आगे बढ़ते हैं. Okay. Now, before we move, quiz भी करेंगे. Sunday you will have a Menti quiz also. Okay. Menti quiz का पूरा detail मैं कल दूंगा. You will have the digital electronics Menti quiz. Now, the password for today's class. So we are right now into GATE crash course. A random password now I am making. Today's PDF will be shared in the Telegram group. Okay. And the PDF will be password protected as always. The password is GATE crash course, in short GCC. The password for the session is going to be GCC, GATE crash course. That is the password for today's PDF. All small GCC. चलो अब question की तरफ आते हैं. Let's move towards the question. All the logic gates shown in the figure have a propagation delay of 20 nanoseconds. Let A equal to C equal to 0 and B equal to 1 until the time T equal to 0, until initial time, and at T equal to 0 all the inputs will flip. Okay, now let us call some of the intermediate variables here. Let's say this is A, this is B bar. Even we need to draw the inverter waveform separately. Now this is A, B, C, this is Z. Let us say this is some variable X, and that is equal to A, B bar. I need to sketch that separately. Now this is Z, which is equal to the X XOR with C. Step by step it is required. Yes, step by step it is required. Okay, so until the time T equal to 0, A and C are 0 but B equal to the 1. A and C are 0 but the B is equal to the 1. तो पहले A और C को हम sketch कर लेते हैं separately. A and C are 0 until the time T equal to 0. What is the time T equal to 0? ये थोड़ा सा बना लेंगे यहाँ पे. Let's say this is your time T equal to 0. This marks the time T equal to 0. इसको हम T equal to 0 का reference ले लेंगे. Okay. So this is what is T equal to 0. For example, I start with A and C are equal to 0, B will be equal to 1 initially, and then they flip. A is equal to 0, it flips and becomes equal to 1. C also was 0, it flips and it becomes equal to 1. B was equal to 1, it flips and it becomes equal to 0. ठीक है? This is the given information. Very important question, dear. Very important question. Right. Now, to come to the output waveform, see guys, in this delay based question you should go step by step drawing the output of every gate. So the first gate you see is the inverter, so you should separately draw B bar. Here. Okay, now all the logic gates, even inverter, all of them have a propagation delay of 20 nanoseconds. All of them have a delay of 20 nanoseconds. All of them have the delay of 20 nanoseconds. That means the waveform of B will be inverted, but after 20 nanoseconds. After what? After the 20 nanoseconds. The waveform of B will be inverted, but after the 20 nanoseconds. Okay. Okay, so let me separately draw here the waveform for the B bar. If it was 1 initially, its complement will be 0 and then it inverts. But will it invert immediately? No, it will invert after 20. So, before we move ahead, let us say this is 20. Let us say this is the 20. Let us say this is the 20 nanoseconds mark. Okay. Okay, so it was पहले इनको हम continue कर देते हैं. It will remain in, this will remain in the same state. A and C have switched and they will remain 1. B was 1 and then it remains to be 0 after initial time. B bar will be starting at 0 and after switching it becomes 1. And sorry, switching will happen after 20 seconds, after 20 nanoseconds. After 20 it switches and then it remains to be 1. Then it remains to be 1. This is up to B bar. This is up to the B bar. Next gate is the output X. X is A in B bar. It is the multiplication of A and B bar. It is the multiplication of A and B bar. This will produce X. This will produce X. This will produce the X, right? So what is the X waveform? Multiply them. Now what is the output of AND gate? If any of the input is 0, output will be 0. Whenever both inputs are high, then only the output will be high. So देखो, A and B bar. This is starting at 0, na? Then it became 1. ठीक है. So A and B bar, 0 into 0 is 0. So starts at 0, right? X starts at 0. 0 into 0. Now this is 1 and 0. Look into this. A and B bar. 1 into 0 is also 0. So it remains at 0. Now everybody focus here. Everybody focus here. This is the time t equal to 20 when these two are equal to 1. A and B bar. Both are equal to the 1. 1 into 1 is 1. Output of AND gate will become 1. But after delay. How much delay? 20 more nanoseconds. So after 20 more nanoseconds, it is going to become high. So let me here draw one more time. That should be 20 nanoseconds. I'm drawing one more waveform here. I'm drawing the one more time mark here, and that time mark here is the 40 nanoseconds. And 20 plus 20, that is why I'm going for 40. After 20 more nanoseconds, the output of AND gate become high. Before that, this was equal to the 0. X, output of AND gate. Okay, output of AND gate. Right. Ye tha NOT gate. Then finally you have an XOR gate which will take the XOR of X and C. Which will take the XOR of X and C, and that output is known as Z. So now I present you the Z waveform. What is the initial value of Z? What should be the initial value of the Z? Dhyan dena. Now I present you the Z waveform. What should be the initial value of Z? Z is the XOR of X and C. Right. Z is the XOR of X and C. X XOR C. Right. X XOR C. Right. XOR will produce a high output when both the bits are different. When both the bits are different. दोनों को different करना पड़ेगा. Right. X and C. Right. X and C. X and C. दोनों को different करना पड़ेगा. तो different यहाँ पे तो same है. Both are same. So output will start with 0 level. Right. Now look into this. These two become different. Whenever the input is different, whenever the input bits are different, output will be high. Output will be high. So what is 1 0 different? Output will be high, but after delay, how much delay? 20 more. How much delay? 20 more. So here, exactly at here. Okay, this becomes high. Now keep tracing. Keep tracing X and C. This was 1 0 different. Now this is 1 0. It will remain. It is different. No problem. This is again 1 0 different. The output will keep going high. Output will keep going high, right? But at this instant, after 40 nanoseconds, if you pay attention, after 40 nanoseconds, if you pay attention, both become 1 1. Both become 1 1. What to do now? Both are going to become 1 1. What to do now? What to do? 1 1 means same, and if both the input bits are same, output of XOR will be 0. After how much time? After the delay time. Delay time is 20. 40 plus 20 kijiye. 40 plus 20 is 60. 60. So after 60, right, after 60, first let me draw one more time waveform here that will correspond to the time stamp of 60. this will correspond to the time stamp of 60. इसको थोड़ा सा ऊपर लिख देते हैं. This one is 40, this one is 60. Hope that is visible. Perfect. Okay, and now this will remain 1 up to the 60. After that it becomes 0. Now the question was very beautiful question. The question was the output z equal to 1 is there for how much duration? Output remains high for how much duration? Right, the output remains high from 20 to 60 and that is 40 nanoseconds duration. कितना हुआ? 40 nanoseconds duration. Output remains high for 40 nanoseconds duration. The output remains high for a 40 nanoseconds duration. कितना? 40 nanoseconds duration. The output remains high for 40 nanoseconds duration. 40 nanoseconds duration. Perfect. 40 nanoseconds duration. Cool. Very good question. This is what is the type of question that you should practice. These can be expected for 2 marks level. Logic gate से ये अच्छा solid question बनेगा ना when you are solving with delays, not like a regular. That can also be expected one marker question. That can also be expected one marker question. Okay, there's nothing great there. Right. Now let us come to the next very important point. Okay, because the time is already 10:30. We have a 1.5 hour session, but no problem. Before we lose out of time, let us cover the very important topic and very important concept of prime implicants and essential prime implicants, because I know many students are confused in this. Yeah, maybe not much comfortable in this. I'll give you the shortcut for this. समझना how to calculate the prime implicant and essential prime implicant. Okay, first of all, what do you mean by prime implicant and what do you mean by essential? Not by the language, not by the definition. Definition is known, right? Definition is known. It is written in front of you. What is the actual meaning of it? Then yeah, what is SPI, RPI, that also I'll tell you. Okay, सब कुछ समझाएंगे. To explain all of this, what is prime implicant, what is essential prime implicant, let's take one example. Right, this is one example question. Okay, let me explain you one example, then I'll give you a question. So there is a function summation of the minterm 0, 2, 3, 5, 7. Question क्या आ सकता है? Question can be tell me the number of prime implicant, tell me the number of essential prime implicant, tell me the SPI, right? Tell me the RPI. I'll explain you all this term, right? Tell me what are the EPIs. Don't only tell me the number. What are the EPIs? Okay. So let us understand this, and the best method of solving it, the shortcut method of solving it is K-map. Now this is a 3 variable function. Minterm is only up to 7. So there is a 3 variable function given to you, f, a, b, c, that is summation of the minterms. क्या given है? 0, 2, 3, 5, 7. 0, 2, 3, 5, 7. Okay. So let's take the K-map corresponding to it first of all. Understand its shortcut. Sorry. Let this be A, this is BC, 0, 0, 1, 0, 1, 1, 1, 1, 0. Gray codes will be followed, and this is 0, 1. Okay. Now everybody mark down the minterms. So what are the minterms given to me? 0, 2, 3, 5, 7. Okay, this is what is the plotting of the function. This is the plotting of the function. ठीक है, इसको इस तरीके से प्लॉट कर दिया है हमने. 5, 7. Now, what are prime implicants? What are prime implicants? Every product term in the K-map, not in the K-map, every product term corresponding to the function which cannot be combined, paired, grouped with any other ones, with any other term, is a prime implicant. In short, if I tell you, every possible pair if you find out, यहाँ पे समझना, right? Everybody, listen to me very deeply right now. Look into this one, right? Yeah, look into this one. First, look into this one. This is a minterm number 5. This is the minterm number 5. Minterm number 5 बोले तो 101 A B bar C. A B bar C. This is a product term. This is a minterm and this is a product term. Is it a prime implicant? ध्यान से सुनना. Is this a prime implicant? Every product term is a prime implicant if it cannot be reduced further. Let me put it even more simple. Every product term is a prime implicant if it cannot be reduced further. अगर उसको फर्दर रिड्यूस नहीं किया जा सके, एंड हाउ टू रिड्यूस इन द के मैप या हाउ टू रिड्यूस इन जनरल, व्हेन इट कैन बी कंबाइंड, व्हेन इट कैन बी पेयर्ड और ग्रुप्ड. It may be a pair of 2 or it may be a group of 4 or a group of 8 or anything, right? So is it a prime implicant? It's a product term, but is it a prime implicant? No, because I can pair it with the adjacent one. I can pair this with the adjacent one, and when I pair it, it is going to reduce one variable. One pair will reduce one variable. So it is going to reduce one variable. एकदम sorted है. It is going to reduce one variable, right? चलो, so this is not a prime implicant. I hope that is clear. This is not a prime implicant. Acha, now let's move forward. So okay, let me pair this. What is this pair? What is this pair? If I write down the regions also, this is the portion where A is high, this is B, right, and this is what we normally call it as the C, the regions corresponding to A, B, C. So this lies where? Okay, this is lying in A and C. This is AC. This is AC. This is a prime implicant. This is a prime implicant because it cannot be further grouped. How to make it group? Either it is a group of 2 or group of 4 or a group of 8. You can only group in the form of 2 power n in the K map, na? You cannot make a group of 3. ऐसा कोई group तो नहीं बनता है, right? And you can't group diagonally also. You can only group adjacent or vertical blocks. So can it be further grouped? Can it be further combined? Not possible, right? So if there is a product term which can be no longer combined, अब इसको आप किसी के साथ combine नहीं कर सकते, then that is a prime implicant. Moral of the story is कि treat it as a K-map problem and see how many pairs or how many groups you are able to make. This is a valid group, na? Whether it is going to come in the answer or not, that is not matter. How many possible pairs? It is a puzzle question. Puzzle बना लेंगे. How many pairs or how many groups? Whether it is a pair or whether it is a pair or whether it is a quad, whether it is a octa, whatever you are able to make from the K-map, make. All such will be the prime implicant. The condition is, listen to me. The condition is, suppose यहाँ पे भी 1 होता. Suppose if this was 1. Suppose for a moment. So then this pair will not be a prime implicant. Then this pair will not be a prime implicant. Okay. Because this pair and this pair will make a quad, na? So if a pair can be combined, please combine it and give me the final answer. That is the prime implicant, right? So if there was a 1 here, then this pair will not be a prime implicant because it can be reduced. It can be combined further, right? But as of now, there is no single one. So what about this pair? This is also a prime implicant. This is also a prime implicant. We will take 1 or 2 more questions, then it will be set. If there is any confusion, ekdam set ho jayega. Patience rakhenge. What is this? This is above A, this is A bar, and within B, this is A bar B. Acha, let me keep writing the PIs here. What are the PIs? Right now it is AC, A bar B. Next. So next. Right. What about this one? Right. Can I take it as a prime implicant? Can you group this? If it was alone, then you can call it as prime implicant. But can you group it? Yes. First, last columns are adjacent. So this is not a prime implicant because you can group this. Ye lijiye. I group this here. Right. First and last columns are adjacent. Now what is this? This is above A, this is A bar, and this is the C portion. So this is outside C. So this is C bar, A bar, C bar. There is one more PI, A bar, CR, A bar, C bar. Is this enough? I am not telling you what is going to come in the answer of K-map. See, listen to me. If you have to write down what is the minimized expression using K-map, if you have to write down the answer using the K-map, you will probably write down the answer as, these 3. But I will tell you one more possibility. Yes, very correct. Dekho, what about this one? What about this vertical pair? Forget, I'm telling you, when you are finding PI, forget what is going to come in the final answer of K-map. The question has not asked you what is the minimum SOP expression, right? What is the minimum SOP expression? The question is not asking you. Question is prime implicant. And every product term, every pair or every group which cannot be combined further is a prime implicant. Now this is a vertical pair. Can you combine it with anything else? Bhai, 2 plus 2 can make 4, na? You can only make group of 2 or group of 4. 2 or 4, 2 or 4. So to combine it, you should have a 1 here. Then it becomes quad. But unfortunately, there is no 1 here. or you should have a 1 here, then again it becomes a chord, but again unfortunately you don't have the 1 here, so it cannot be further combined and reduced, right? It cannot be further combined and reduced, right? What is this? This lies in B and C. This is BC, and this is also a prime implicant. This is also a prime implicant. ये भी हुआ prime implicant. Now, what is essential prime implicant? So how many PIs are there? How many PIs are there? There are 4 PIs are there. Now, listen to the EPI procedure. Let me complete. Listen to the EPI procedure. EPI procedure के लिए आप क्या करेंगे? नहीं, green will not be visible. Let me try something else. For EPI, na, highlight the ones which are covered under a single group. Highlight the one. Look at this poor minterm. Look at this poor minterm. Right? Highlight this. Why? Because it is covered under a single group. It is covered under a single group A bar C bar. Now the point is कि suppose you miss out A bar C bar. This is A bar C bar ना. Suppose you miss out A bar C bar. Suppose you miss out A bar C bar. भूल जाइए, छोड़ देते हैं इसको. If you miss this A bar C bar, you know what is going to happen? You know what is going to happen? You are going to miss this minterm, and then the function is disturbed. Then this function is no longer containing the M0. Are you getting it? That means at any cost, किसी भी कीमत पे, at any cost, I cannot miss this group. If I miss this group, if I miss the minterm, I change my functionality. I change the Boolean function. So I cannot miss this prime implicant. तो ये prime implicant क्या हुआ? ये prime implicant जरूरी हो गया. What is this prime implicant? It becomes essential, necessary. You can't live without it. This becomes essential for you. This becomes essential for you. That is what is the concept of EPI, essential prime implicant, जो बहुत जरूरी है, जिसके बिना आप आगे नहीं जा सकते. That you can't miss at any cost. That you can't miss at any cost. Right? So I bubble this. I highlight this. And this is EPI. Right? So which one? A bar, C bar. This one is EPI. This is one EPI. Next. Again, this poor fellow. This poor fellow. Don't talk about this. What about this fellow? It can be either clubbed with the vertical or it can be taken with the horizontal. There are two options to save it. There are two options to save it. It has two options. But it has only, this minterm is covered only under a single group. Right? Which group? AC. So that AC becomes essential. You can't miss the AC. You can't live without AC. It is essential. Jaruri. That AC is essential. Anything else? Right? You can't highlight this. You can't highlight this. What about this minterm? This is also covered into two groups. The shortcut is look into those minterms which are covered under a single group. That particular group is essential. So how many EPIs? Only two EPIs. How many EPIs? Sir, EPIs तो only two है. What are those EPIs? What are those EPIs? Right. What are those EPIs? It is AC, A bar, C bar, AC, A bar, C bar. Now look into the function. Right. Of course, whatever is essential, I've told you, there are two things you can't live without. And those two things here is AC plus A bar, C bar. Those two things is AC plus A bar, C bar. But the problem is, dear, the problem is, once again look into the problem. Once again look into the problem. Once again look into the problem. Okay, so if I take the AC, right? Okay. This is what is A, this was C, this is B. If I take the AC, right, this is AC. If I take the A bar, C bar, this is A bar, C bar. All my dear students, this is the AC, right, this is the A bar, C bar. But if I only write down the essential terms, then also still I am missing one thing. What is that one thing? What is that one thing? This particular minterm still went missing. This particular minterm still went missing. This is a minterm still went missing. Now how to cover this minterm? How to cover this minterm? This is also to be covered, but as seen in the previous K-map, this is under two groups, a vertical one or a horizontal one. Which one to take? Which one to take? Your choice, dear. Your choice. You know, you have studied K-maps earlier and you know there can be multiple options corresponding to a K-map, right? So if you take the horizontal wala, then the answer is A bar B, right? Then this answer, this can be taken under A bar B, or if you take vertical wala, then the answer is BC. Then the answer is BC. Then the answer is BC. So my answer is A bar B or BC, any one of them. Now please pay attention. इसको थोड़ा सा break कर लेते, right? So my answer is, pay attention to this answer. My answer is AC plus A bar C bar plus any one of the two. If I take A bar B, or second case लेते, let me write down both the answer. F min is AC plus A bar C bar plus I can take BC. Now please pay attention. AC plus A bar C bar, either it is first answer or second answer, both are coming. I don't have any choice here. Both are coming. So why both are coming? Because we know they are the EPI. But out of the A bar B or BC, there is a choice. You can choose anyone. Now let's say I chose A bar B. Then dear, the A bar B is known as SPI, selective prime implicant. A bar B in this case is selective prime implicant. What happens with the BC here? BC becomes the redundant. BC becomes the redundant. BC you can reduce, you don't need. Okay. But somebody else will come and say, dear sir, my wish, I want to choose BC. I want to go ahead with the BC. Then for that particular bhai sahab, BC becomes the SPI. BC becomes the SPI. He has selected BC, that is selective prime implicant. So what about the A bar B there? So here A bar B is known as RPI, redundant prime implicant. That is why in the questions, most commonly, they don't ask what is the RPI, they ask number of RPI. Because RPI for me can be different, RPI for you can be different. Na? There are two options. I can go with answer 1 or answer 2, right? If I go with answer number 1, RPI is BC. If I go with answer number 2, A bar B is the RPI. Is that okay? That is why commonly in the questions they don't ask RPI, they ask the number. Yeah, but that is very sure. One is redundant, one is selective, and 2 are EPIs. So if I have a look into this distribution, if I have a look into this clear distribution, right, I can say that the prime implicants can be essential or non-essential. Definitely these two are essential. Compulsory, right? But these two cannot be essential. इनमें से एक आएगा, एक जाएगा. एक की entry होगी, एक की छुट्टी होगी. Right? These two are non-essential. Right? Non-essential. Right? But non-essential में से some of them can be RPI, some of them can be SPI. This is the categorization. Some of them can be RPI, some of them can be SPI. This is the categorization. Understand this? Okay. And then the minimum expression is sum of all EPIs. That is compulsory. EPIs will come plus some non-essential PIs. Right? Which non-essentials that you select? That is SPI. That is the SPI. Okay. This particular is the flow chart summarizing the type of prime implicants. I hope that is clear to everybody. Yes, Ravi. Absolutely. MSQs are possible here. Absolutely. The MSQs are possible here. The MSQs are possible. लो आपने बोला ये लीजिए. Take this MSQ. MSQ. If the question was clear, let's try one 4 variable also. One MSQ. Which of the following is true for the following function? Which of the following is true for the following function? Summation of the minterm 0, 2, 3, 5, 7, 8, 9, 10, 11, 13, 15. 0, 2, 3, 5, 7, 8, 9, 10, 11, 13, 15. Come on. Number of PIs, number of EPIs, number of RPIs. Okay. MSQ, मल्टीपल सेलेक्ट है भाई साहब. विच ऑफ द फॉलोइंग इज ट्रू? चलो, सो 0, 2, 3, 5, 7, 8, 9, 10, 11, 13, 15. Okay, let me mark them quickly. Okay, let me also write down A, B, C, D. 4 variable case it is. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Right. This is the place where A is high. This is the place where B is high. 0, 1, 1, 1. B is high. Then C. 1, 1, 1, 0. 0, 1, 1, 1. Last two. Last में देखोगे 1, 1 है. This is D. Now min terms 0, 2, 3, 5, 7, 0, 2, 3, 5, 7, 8, 9, 10, 11, 8, 9, 10, 11, 8, 9, 10, 11, 13, 15, 12, 13, 15. This is the K map. The shortcut method is through the K map. This is the K map. Now tell me, okay, now tell me the number of PIs. Let's take the PIs. Right. All possible groups that cannot be further reduced. ये ध्यान रखना है. Right. So guys, once again, is this a PI now? Everybody think. Answer in your brain. Answer in. You can answer silently also. No need to reply. But think. Is this PI? It's a group. It will be a product term. It will be a product term that is equal to A bar B D. But is it a PI? Nah, because it can be combined with another pair adjacent hai to make a quad, and when it can be combined with something else, it cannot be a PI, right? Okay, but what about the quad? Is this a PI? Quad can only be combined with another quad to make a octa, right? So ye to definitely PI hai. This is PI, that is coming, that is BD. Okay, next, sir, this is also a quad. This is also a quad. See, what is going to come in the K-map answer? Nobody is caring here because the question is not about K-map. The question is about PI, EPI, RPI, SPI. Right. So all possible groups or quads or octas, whatever you can make. So this is one more octa, AD. I'll call it as AD. Next, sir, और बोलिए these 4 corner ones, we know that all corners are adjacent in the 4 variable K map, right? So 4 corner ones also coming up, right? So if I take the 4 corner ones, that is B bar, D bar, one more, right? One more. The list of PIs is getting ready, right? I started with BD, then I have AD, then I have the B bar, D bar. और आगे बोलिए, आगे बताइए, right? Now look into this. Linear straight line, horizontal straight line, that is also a quad, na? That is also a quad. Okay, yeah, forming everything, Ravi. Wait, that is also a quad. I'm just looking into that only. So what is this? This is A and outside B. A, B bar. One more list. आ जाते हैं ना अभी. See the other possibilities now. Okay, now look into this. This is a pair, but this is not going to be a PI. Pair plus one more pair. First and last rows are also adjacent. Pair plus pair, again a quad. One more quad ready for you. Coming up from here. Okay, what is this quad? Equal to B bar and within C. It is B bar C. और बोलिए. Now tell me anything else. Right, there is no vertical column, very clear. There was only one horizontal row, quad, complete. This is a quad. This is also a quad. Tell me any other possibility. You cannot make this here. Yeah, this is one column. Column is here. Sorry, I missed this. So, ye aaya column. Right, this is one column which is C, D. One more entry coming up here. C, D. B bar C नहीं लिखा क्या मैंने? Let me write down that also. पहले we have written here B bar C. This is CD. Correct है? So there is one more vertical quad as well. Third column itself is a quad. Now tell me, sir. How many PIs are there? Number of PIs are 6. Yes, the number of PIs are 1, 2, 3, 4, 5, 6. Number of PIs are 6. Now EPIs, simple, star mark method, bubble method. Star mark karenge. Okay, look into this. This is a minterm. This is a minterm which is there in a single group. This is a minterm there in the single group. This is a minterm there in the single group. So I'll highlight this. And that group, which group it is? The corner ones B bar, D bar. The corner ones B bar, D bar. That is essential. Now keep tracing. It is in multiple groups. No need to highlight. This is also in multiple group. No need to highlight. Look into this minterm. Right? Minterm, bubble or highlight those minterms which are under a single term. Single group. Yes, this is under a single group. ठीक है, यहाँ पे कोई भसड़ नहीं है. This is under a single group. Right? And that group is BD. That group is BD. Right? This is under multi-group. This is multi. This is under multiple group. This is under two groups. This is under two groups. This is under multiple groups. This is also under multiple groups. No. So only two EPIs. So the number of EPIs is 2. Option number A भी सही हो गया. Let us write down the list also. EPI is equal to 2. Is equal to 2. What are that? BD, B bar, D bar. Right. अब और क्या पूछा है? BD plus D bar, D bar are the PI as well as the EPI. Number of redundant prime implicant. Now how will you tell what is the number of redundant prime implicant? How will you decide the number of redundant prime implicant? How will you decide the number of redundant prime implicant? Okay, for that I will take the fresh. Okay, for that to explain you can draw that there as well. But to explain you, I will take the fresh K map. Okay, and my minterms are 0, 2, 3 और क्या क्या है 0, 2, 3, 5, 7, 5, 7, 8, 9, 10, 11, 13, 15. Out of which my EPI are BD plus B bar D bar. BD plus B bar D bar. ये ले लेते हैं BD को ले लेते हैं. Where is the BD? This was the BD and B bar D bar means the corner ones. अब बताइए. Which of them is redundant? Which of them is selective? How many redundant and how many? See, that is why redundant can be your choice, but how many? That can be fixed. सोचते, right? That can be fixed. I need to cover these two. What is the possibility? Now to cover these two, what is the possibility? To cover these two, what is the possibility? It will not be taken as pair. It has to be taken as quad. Okay. Can you combine these two? You can combine them as the quad. As the quad. What quad? ऊपर वाला or the row. Or the row. Right. So this can be taken under which quad? This can be either taken as this quad. What was this quad? AD. This is the AD or this one, the horizontal row. The horizontal row which is AB bar. So one of them is selective, one of them is redundant. One of them is selective, one of them is redundant. Now there is only one minterm left. There is only one minterm left. There is only one minterm left. Where to cover this minterm? Where to cover this minterm? Now there are again, this can be taken in this quad, first and last row. This quad, the first and last row, that is B bar C. इसके लिए you have B bar C, or this can be taken with the third column answer. The entire third column, na? The entire third column. The entire third column, that is CD or CD. That means guys, the answer is PI were 6, but how many EPI? EPI is 2. ये भी हमने देख लिया. But other than the EPI also, you have to select 2. You have to select 2, right? So how many non-essential सबसे पहले? How many non-essential PI? Out of the 6, only 2 are essential. So of course 4 are non-essential. Out of this 4 non-essential, how many are to be selected? 2, right? 1 from here, 1 from here. So of course, how many to be reduced? How many to be reduced? How many to be reduced? 2. That is why only the number can be a good question. What to be reduced? Right? You may reduce this or this. You may reduce this or this. There can be 4 possibilities. So they will not ask, tell the RPIs, tell the number of RPI is what is the question that they can make. Okay. Now if I trace the entire question, the number of essential prime implicant 2 hai kya? Sir, bilkul 2. Sorry, essential prime implicant 2, perfect. Total prime implicant 6. BD, B bar, D bar are the PI as well as the EPI. Look into this. BD B bar D bar. Yes, that is correct. Right. Number of RPI is 1. That is wrong. Right. The number of RPI is not 1. That is going to be 2. Right. So what is the answer for the multiple select question? A good multiple select question. The answer is A, B, D. Abraham D. Villiers. The correct answer for the question is A, B, D. The Abraham D. Villiers. The Abraham D. Villiers. All right, everybody. A, B, D. Okay. Chalo, so hope the PI and EPI is also now with this question, EPI, RPI, SPI, everything would be clear to you, right? Which of the following is not an essential prime implicant? A homework, do mention the answer of this homework in the comment box. Do not forget to mention the answer of the question in comment box. Now the function is, last time if it is not visible, I will write down the function here, which is product of the max term. The product of the max terms 1, 9, 11, 12, 14. But EPIs, they are formed from PIs, right? And PI is a product term, na? PI is a product term which cannot be reduced further. That is what I told in the beginning. So you need product terms. Max term nahi chahiye. The first step is convert into the min-term list. How to convert into the min-term list, that you will complete. But to start the PI or EPI question, if the question is given in max term list form, product of max term, first convert into summation of min term. What is the rule? All those min terms, all those integers which are in the max term, they will not come here. Yeah, vice versa, let me say. All those integers which are missing in the max term list, they should come in the min term list. They should come in the min term list. They should come in the min term list. बहुत ही बढ़िया. ठीक है, चलो, this is a homework for you. That's it. I hope you have enjoyed the session. Okay, it's been 2 hours. I planned for 1.5 hours. It's been 2 hours. We have covered several important topics from Boolean and the logic gates. See you tomorrow. Okay, let's see. Goodbye to each other. We shall once again connect tomorrow at the same time of 9 p.m. Tomorrow, 9 p.m. Right, and tomorrow in this crash course, let us revise the important fundamentals of combinational circuits. Combinational circuits. Important fundamentals of the combinational circuits. Telegram, yeah, I'll share you the Telegram link as well. Just wait a moment. Just wait a moment. थोड़ा सा wait कीजिए. Just give me a minute. Here it is, the link of Telegram. You will get the today's PDF, password protected in this Telegram. Password I have told you in the session in between, somewhere in between. That is already we have disclosed that password. So join this Telegram, get the access to PDF. Tomorrow combinational circuit. Sequential circuits is little bit more important. So sequential circuit I will break it into 2 classes. One is flip flop, one is for counter dedicatedly. One is for flip flop, one is the counter. Chalo guys, bye bye. Right. Yeah, that it's your choice, but 4 AM is a pretty much good time to study as well. Okay, but for that, sleep early. It's not like, you know, you're sleepy at that time. Sleep at least by 12 or so if you're trying to wake up at 4. Chalo guys, bye bye, good night. See you tomorrow at 9 p.m. Once again, this is Rakesh Sir signing off.